Hello everyone, today I'll be going over 2024 Fermat Part B from questions 11 to question 20. So let's get started with question number 11. So figure 1 shows an arrangement of 3 lines with 1 intersection point, and figure 2 shows an arrangement of 3 lines with 3 intersection points. What is the maximum number of intersection points that can appear in an arrangement of 4 lines? So having 4 lines, that means that each of the 4 lines can intersect with the other 3 lines. And so then we would just do 4 times 3, which is equal to 12. But then the trick is we need to divide this by 2 because each of the point of intersection is considered as twice. So the final answer would be 6. We could also double check this by just drawing it. So this is my 2 lines and this will be my 3rd line, and my 4th line could be somewhere like this, so that it'll be 1 2 3 4 5 6. So there will be a total of 6 intersections maximum. Okay, the second question, the number 5 6 10 17 21 are rearranged so that the first 3 numbers are equal to the sum of last 3 numbers. So we have 1 2 3 4 5, and so this middle number would be used twice, something like this. So how I did was just trial and error. So we also know that here these 2 have to be same as these 2, and some things that would work is 6 plus 21 equals to 10 plus 17. So, and that would make our middle number equal to 5. And that is just our final answer because it's asking for the middle number. So 5 would be our final answer after some trial and error. Question number 13. For some integer m and n, the expression x plus m times x plus n is equal to the quadratic expression in x with a constant term of minus 12, which of the following cannot be a value of m. So if we expand this expression, we get something like x squared plus m plus n x plus mn, and the question is saying that the constant term is equal to negative 12. So we just have to find m and n that is a divisor of 12, and the only thing that is not in these options is 5. 5 times something, an integer, cannot equal to negative 12, whereas all the other multiple choice options, it's possible. So our final answer would be E. And the question number 14, the diagram shows this, and the question is asking for the perimeter of AB DE. And so this is just using special triangles, and since we know that AB is equal to root 3, we know that BC would be 1 because it's 1 to root 3 to 2 ratio here, and this is right triangle, and we know that this is a right triangle, so our angle here is 30 degrees because 60 plus 90 plus 30 is 180, and we get another special triangle here, so we could just build up like this. And ACE is also a right isosceles, so we know that AE is 2 root 2 with our special triangle rules. So our final answer would be root 3 plus 1 plus root 3 plus 1 plus 2 root 2, which gives us 2 plus 2 root 2 plus 2 root 3. So our final answer would be E. Okay, moving on. Anila's grandmother wakes up at the same time every day and follows the same routine. She gets her coffee 1 hour after she wakes up, which takes 10 minutes. She takes a shower 2 hours, and so on. And the question asks, if Anila's grandmother woke up 5 minutes ago, what will be she doing in 197 hours? So since we know that the grandmother does the same thing every day, we could simplify this 197 hours by subtracting by how many days it has passed. So in one day there's 24 hours, And if we multiply this by, let's say, around 8, we get 192 hours. And that's just perfect enough to subtract 197 hours from 192 hours, which gives us 5 hours. So basically 197 hours is equivalent to 8 days and 5 hours. So, and we don't need to know about these 5 hours because the grandma would be doing the same thing, and the only thing we're curious about is this 5 hours. So what will she be doing after 5 hours after she woke up? She would be doing some yoga. Since it's 5 minutes ago, she would be 5 minutes into doing yoga. So our final answer would be doing some yoga. C. Okay, number 16. Francesca put one of the integers 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 in each of the 9 squares. No integers used twice, and she calculated the product of the 3 integers in each row and wrote the products to the right of the corresponding rows. So since these are all integers, which integer was in the squared marked n? So off the bat, we need to find some common divisors of these products. So as for me, I see 21 as 3 times 7, and I see 56 as 8 times 7. And here we already know that this only 7 works here because 7 is a common divisor of 21 and 56. And we also know that here the middle square, 108 is 12 times 9, and 135 is 9 times 15. And I believe that it's highly likely that the middle is 9 because we have the same 9. I guess 3 also works, but the 3 has to go in one of here or here because 3 times 7 is 21. So I think 9 is the better option here. Okay, so after that, another thing that I find is that 135 has a 5 as its divisor, and 160 also gets divided by 5, and that's only the product of 5 there, so I think the 5 should also go here. So after that is kind of like, is actually not that hard because after this we could have an option of 3 here and a 1 here, or we could also have 1 here or 3, but that would not work, and it would be 3 here because 3 times 9 times 5 is equal to 135. So this automatically gives us 1 here. And next, let's see. So we have these 2 boxes, which could be either 2 and 4 or 4 and 2. And actually both could work, but so if we try 4 and 2 here first, then we get 5 times 4 is 20, and 20 times 8 is equal to 160. So this automatically leaves us with our n, which is 2 times 9 is 18, and 18 times 6 is equal to 108, which works perfectly fine. We never use the same digits twice, so that would be our final answer, C. Question number 17. Each of the variable a, b, c, d, e represents a positive integer with the properties of such following equations, and which of the variables have the greatest value. So right off the bat, we know that we could just cancel both these, so we get b is greater than a, and for second equation we get c is greater than b2. So this ultimately leads us to having c the greatest, b, then a. And if we look we know that D is equal to C minus B, and this automatically shows that D cannot be greater than C because we're subtracting B, a positive integer, from C, and that equals to D. And if we look at the last one, A plus C equals B plus E, if we isolate E, then we get C plus A minus B. And we know that A minus B is a negative number from here. And that means that E is also less than C because we're adding a negative number to C, which means that E would be less than C. So ultimately our greatest integer would be C, and that will be our final answer. Question number 18. Suppose that x and y are real numbers that satisfy the following two equations. What is the value of xy? So when I look at this two equation, I see the relationship of 3 being squared, x being squared, 2 being squared, y being squared. So let's square these equations to make the equation so that it's similar to the second equation. So we get, if we square this, we get 9x squared plus 4y squared and plus 3 times 2 times 2, so 12xy, which is equal to 36. And the second equation is just the same thing. We did not touch anything, and we could also subtract these two equations so that we could get rid of the 9x squared, the 4y squared, and ultimately we get 12xy equal to 36 minus 468. So 432, so we get minus 432. And if we just divide both sides by 12, we could get the value of xy, and xy would be negative 432 divided by 12, which gives us some value that we need to plug into our calculator, and that would give us negative 36. And that would be our final answer to this question. Pretty simple, right? If we know that we need to square both sides, it is not that hard. And question number 19, 3 standard six-sided dice are rolled. The sum of the 3 numbers rolled, represented as S, is determined. The probability that S is greater than 5 is closest to. Okay, so since there are way less occasions of calculating when S is less or equal to 5, we will subtract this from 1 to get our probability. So what are the different cases where the sum would be less or equal to 5? So first, we have a case of 1, 1, 1. Second, we have a case of 1, 1, 2. And third, we have a case of 1, 1, 3. And fourth, we have a case of 2, 2, 1. And here, there's only one time because there's no other different distributions to it. But for the case of 1, 1, 2, it could be 1, 1, 2, 1, 2, 1, or 2, 1, 1. So there's 3 times cases. Same thing for 1, 1, 3, there's also 3 times. And same thing for 2, 2, 1, there could be 2, 2, 1, 2, 1, 2, or 1, 2, 2, which is also 3 times. And after that, beyond, all the sum is greater than 5, so these are only our options. So this total 10 times, so 10 possibilities. And we also know that 3 standard dices are rolled, so the total possibility is 6 to the power of 3, which is 216. So the probability that s is less than 5 is equal to 10 over 216. And remember, the question is asking when the probability of s greater than 5. So we are subtracting this from p less or equal to 5, which is 1 minus 10 to the power of 10 over 216, which is 206 over 216. And if we plug this into our calculator, this is somewhat around 0.954. So our final answer would be B. Okay, here we're already at the last question of part B. So a cylinder contains some water, a solid cone with the same height and half the radius of the cylinder is submerged in the water until the circular face of the cone lies flat on the circular base of the cylinder, as shown. Once this is done, the depth of the water is half of the height of the cylinder. If the cone is then removed, the depth of the water will be what fraction of the height of the cylinder? So if we set this radius of the cylinder as 2r, we know that the radius of the cone is just r. And right now, the water is filled half. So this would be 1 over 2h. Well, this whole thing would be h. So when the cone is removed from the cylinder, then the water would decrease, obviously, and it would decrease by the area of this little cutted cone. So let's first calculate the area of the volume of the water first, that is filling up half of the cylinder. So the volume of the water would be, using the formula given here, pi r squared h, it will be 1 over 2h times pi times 2r squared, because the radius is 2r. And if we calculate the volume of the cone, it would be 1 over 3 pi r squared h. And we want to calculate the volume of the shaded area here. And if we so we need to subtract the volume of the cone with this small little cone at the top, which is also the height is 1 over 2h, and the radius of this would be 1 over 2r, due to the similar triangles of if the height is being halved, then the radius is also being halved. So the volume of the small cone is equal to 1 over 3 pi, and the radius is 1 over 2r squared, and multiplied by 1 over 2h. And that gives us pi r squared h over 24. So the shaded area, the volume of the shaded area would be 1 over 3 pi r squared h minus 24 in the denominator and pi r squared h in the numerator. And that will ultimately give us, if we multiply this by 8 and the top by 8, then we get 24 as a common denominator, and 8 pi r squared h minus pi r squared h, which would give us 7 pi r squared h in the numerator. So now we got all the volume that we need. So when this cone is removed, the volume of the water after would be volume of water subtracted by the volume of the shaded volume. And this is ultimately equal to, okay, we forgot to calculate the volume of water, so this gives us 2 pi r squared h. So the volume of water, 2 pi r squared h minus 7 pi r squared h over 24. It gives us 24 as a common denominator, and the numerator we get 48 minus 7, so 41 pi r squared h. So I'm just doing calculations in my head. If you can't, then feel free to write. You'll get the same answer, 41 pi r squared h over 24. And remember, this is the volume of the water after, and the question is asking for what fraction of the height of the cylinder would the water have in height. So this 41 pi r squared h over 24 is equal to 2r squared pi times the new height, which I would represent in h prime. So we're basically calculating h prime. So if we divide both sides by 2r squared pi, then we get h prime equals 24 over 41 pi r squared h over 24 times 2r, something like this, which ultimately gives us 96 over 41 because r squared gets cancelled here and pi gets cancelled, and we get 41h over 96. So ultimately the new height of the water would be 41 over 96 of the actual height of the cylinder. So our final answer would be B. So thank you for going through the solutions with me in this video, and I will see you in the next video.